Okay, to solve this question, I did it using two different methods. The first method, the answer I got was 2.0139834193444 seconds. And the second the answer I got was 1.2347464273359 seconds. And the reason I use two different methods is because of the fact that I think that there is a typo in this problem. It gives us that the angle in which the incline makes with the horizontal is 69.4 degrees. However, I think just looking off the bat, just thinking about that seems so unreasonable for your ramp to look like that. In physics, we're so used to seeing ramps look like this. It just seems like they made a typo here because of the fact that it says with the horizontal. So I'm going to assume for the demonstration of this problem, I'm going to go ahead and assume that this is a typo and they meant to say 69.4 degrees with the vertical. So yeah, and that therefore meaning that the angle with the horizontal would turn out to be 20.6 degrees. If you don't understand how I got that 20.6 degrees, that's totally okay. I'm going to explain it real quickly. So pretty much this is the ramp that I just drew, and this is the angle 69.4 degrees. But to get the 20.6 degrees, all we're doing is doing 90 minus 69.4. And that'll give us this shaded angle right here. That'll give us that shaded angle right here, because this entire angle right here is just 90 degrees. And so we're taking 69.4 and we're subtracting it right there. And then that'll give us this angle right there. And then that's our new ramp right there. That's our new ramp. That is a lot prettier looking and a lot less steep. So that's how I got the 28.6 degrees with horizontal. So I'm going to first go ahead and start out by drawing a diagram, because that's what I like to do with these types of physics problems. So we have 20.6 degrees with horizontal, and then we have our 90 degrees thing, and then the length of the ramp is going to be 4.2 meters. Now what we need to do is first find the height of the ramp. So we can find the height of the ramp by doing the length of the ramp sine theta. And if we plug in our numbers, it's going to be 4.2 sine of 20.6 degrees, which will then give us 1.4777 meters. We're going to go ahead and box that and save that for later. And I'm going to go ahead and just write that on my little diagram right here. And then the next thing we need to know is that this spherical shell, which is the basketball, it is starting at rest. So therefore it has U-grav, which is gravitational potential energy. And as it rolls down, that energy, the gravitational potential energy, is completely turning into a combination of rotational kinetic energy as well as translational kinetic energy. So if we write it out, that would be U grav, U sub G is equal to KE trans plus KE rotational. And if we expand all this out, it's going to be MGH is equal to 1/2 mv squared plus 1/2 I omega squared. And we know that omega is found by doing the velocity over radius. And if we expand this out even more, and which is just simply expanding out the inertia thing for the spherical shell, it's going to be MGH is equal to 1/2 mv squared plus 1/2. Then the inertia is going to be, moment of inertia is going to be 2/3 mr squared. And then the omega squared is just going to be v squared over r squared. And then the r's will cancel out and the m's will cancel out. So then you'd be left with gh is equal to 1/2 v squared plus 1/3 v squared. And if we simplify this down even further, it's going to be gh is equal to 5/6 v squared. And then pretty much to find the velocity, that would be the square root of 1.2 gh. And you may be thinking, wait, hold on, how did we get the 1.2? The 1.2 is found by just doing gh divided by 1.6. So we have I don't even think you can see that, shoot. We have gh all over 5/6. That's the same thing as writing 1/5/6 multiplied by gh. And then 1/5/6 as a decimal is just 1.2. So that's how you get that. And now if we plug in our numbers into that velocity formula, we're going to have square root of 1.2 times by 9.81. Remember the 81, it gives us that 1 that we have to have for acceleration. and all that multiplied by 1.4777, which was the height of the ramp from before that we calculated. And if we solve all of that out, we have the velocity equal to 4.1708 meters per second. We're going to box that and save that for later. And because the acceleration is uniform as it's going down, that means that we can take the greatest velocity, like the peak velocity of the ball, and just divide that by 2. We're just taking the average of that. And pretty much we have V average is equal to 1/2 times by 4.1708 from right there. And then all of that is going to be equal to 2.0854 meters per second. And then we're going to box that, save that for later. And then now we need to find the time, which is going to be equal to the length of the ramp divided by the velocity average. So if we plug in our numbers, it's going to be 4.2 divided by 2.0854. And then when we equal that out, we're going to have the time is equal to 2.0139834193444 seconds. And that is our final answer right there. And the answer, if we assume that it actually is 69.4 degrees with the horizontal, the time should end up being 1.23476273359 seconds. So that's how you get the answers for those, and I hope that helped.